So once again, you might be asking yourself, all of these proofs that we've been looking at with induction in its different flavors and strong induction, etc., have been rather mathy and sort of contrived. So what does an in real life example actually look like? And so that is what these next two videos are about, is going to be showing you how we can use these tools in actually doing some computer science. So we are going to consider radix sort. So radix sort is a very old sort technique, but it still has application today because this particular kind of sorting technique is highly parallelizable. And so because of that, it still has application and use today. So the whole idea behind radix sort is that we have some sort of array of numbers that we need to sort. So here's our array of numbers. We have a 329, 657, 437, 355, etc. And we want to be able to sort these. We want to sort them in ascending order. So what radix sort does is it considers the most and least significant digits. So in particular, in this example, this is the least significant digit over here. It's one farthest to the right, whereas that first one right there is the most significant digit. So how does radix sort actually work? Well, the algorithm behind radix sort is defined as follows, and I will write it out in pseudocode. So here, radix sort takes two inputs. It takes in your input array A as well as D. And this D is going to be the number of digits in the largest number in the array. And in this particular example, they all have the same number of digits, but if you're looking at an array that had maybe, I don't know, a 55 here instead of a 355, you can always pad the left with zeros. So in any case, it's the number of digits in any particular number in A. So the way that this algorithm proceeds is as follows. So it goes for digits I from the least to most significant. And it does the following. It takes A and it replaces it by stable sort A on digit I. So since this is a realistic example, you might not have heard what a stable sorting algorithm is. So a stable sorting algorithm, that's basically one that is order preserving. So for example, if we wanted to sort cat, can, and ant on their very first letter, a stable sorting algorithm would return a result that looked like the following. So a stable sort would, well, A comes before C, so ant would come first. And then here, the first letter, they're both C's. So to be order preserving, I'd have to keep cat in front of can. And that would be a stable sort. A non-stable sort is if it didn't keep this order here. So if we're looking at the first letter, well, indeed, we would still get ant first, but a non-stable sort could switch the order of these two. So notice in this not stable sort, the input had cat coming before can, and here cat comes last after can. But in a stable sort, this order is preserved. So that's what is meant by a stable sort. It's basically order preserving on the particular keys that you're sorting by. Okay, so back to radix sort. We go over the digits from the least to most significant. Then we stable sort our array on digit I, and then replace that back into A. And then that's it. You're done. You simply return A. And that's the entire algorithm. Stable sort from least to most significant digit, and then return it. So for example, in this particular instance of this array, let's go ahead and see what this radix sort would look like. So we first start out with our array. So there's our array that we have. And we're going to go from the least to most significant digit. So we start with the least significant digit, the very first one right here, and we're going to do a stable sort on that. So the smallest one is 5. So in the very first iteration of this for loop here, that number would come up to the very top. And then 7 is the next smallest, least significant digit. And it's stable, so it's going to keep these in the same order. And there we go. We have finished one loop of this. We've gone from the least significant digit. So now we're going to go to the next digit. So here I stable sorted on this first digit. Now I'm going to stable sort on that digit, the second most significant digit. So here, let's see what we get. Well, out of this particular column, our second most significant digit, 2 is the smallest. So we end up with a 329. The next smallest is this 3 here, so we get 437. And then these are both 5s, and since it's a stable sort, we keep it in the same order. Like that. And now I have one more digit to stable sort on, which is the most significant digit here. And so now I'm going to take this and I'm going to sort it, stable sort it on the most significant digit. So if I did that, well, I have 3 is the smallest one, and it's a stable sort, so we're going to keep the 329 as the very first one, 355 as the next one, and then after that, 437, and then 657 right there. And if you check that out, we have now completed our algorithm. We have iterated from our least significant digit to our most significant digit, and this is what we would return. And you can see, yes, indeed, it is sorted. We're going in ascending order here, and this thing really is sorted. So another really cool thing about the radix sort algorithm is, notice nowhere in here did we actually compare the size of any two of these numbers. All we did was look at digits. So radix sort is an example of what's called a non-comparative sort, because nowhere did we actually have to compare the size of two different numbers. We were just looking at individual digits. So what I want to do is, I've proposed this as an algorithm. How do I know it always works? It worked in this example, but how could I actually prove that radix sort works in general? So that's what we'll consider next, is how do you actually prove that this algorithm here really does what it says it does and returns for you a sorted array. And no surprise, we're going to be using induction to be able to show that.